Hello future engineers, here is a video in one of the problems final given in the final summative exam or final exam in structural theory or structural analysis. This is determining the bar force of an indeterminate truss and the corresponding deflection at a specified joint or desired joint. This is indeterminate to the first degree. So here's the problem. Determine the bar force of member CE. E is 200 gigapascals. Cross-sectional areas in millimeter square for outer member 750, inner 500. Also determine the vertical deflection at E. So here's the given truss. And since this is already structural analysis, we proceed as follows. So let's mark the joints as the following: the slope of the members, 3 vertical, 4 horizontal, 5 hypotenuse, as well as for these diagonal members. Then I apply a load, invented load P that does not exist, just for determining the vertical deflection at E, and it is upward. And we proceed at A, show that at A summation forces Y, the force in member AE is 75 and it is constant, 75 kilonewtons tension. Then summation forces X, you'll get negative 60. Then proceed to joint E, mark the members as the following. This is the bar force, the redundant force, member CE, because we solved this by least torque. Then BE stress 1, DE stress 2. So summation forces X at E, these are the reactions, by the way. Summation of moment at D first, then you'll get this reaction. You show this in terms of P, and it is rightward. Then of course there's no other inclined load. Summation forces X, they are numerically equal but leftward at D. Summation forces Y, then the reaction here is 90 plus 45 minus P, or 135 minus P. So after A, you proceed to E, summation forces X first, and show that S2 is 60 minus 0.8 Q. Summation forces Y, show that S1 is equal to negative 0.6 Q plus P minus 45. Then you proceed to joint B, labeling this other diagonal as S3, then this member BC S4. So summation of forces along Y first to express S3 as Q minus 5 thirds P plus 225. Then summation forces X, S4 is negative zero point 0.8 Q plus 4 thirds P minus 240. Then you proceed to join C, summation forces Y, to solve for S5 and show that S5 is negative zero point 0.6 Q. Then check equilibrium at C if summation forces X is 0. Then at D, summation forces X, summation forces Y, you have to check that if they are also 0. So I already checked this. They are 0, so we proceed by tabulating the stresses of members. Then I use Castigliano's second theorem. So we have members Q 1, 2, 3, 4, 5, because these two members here have constant stresses or forces, therefore they have no contribution to the force or effect to force in member CE, which is Q. Then member Q, the partial derivative of S with respect to Q is 1, with respect to P 0, length is 5, so 5Q. Uh, it is an inner member, so we have color coding here, green. S partial of S with respect to P times length is 0. Member 1, this is the stress with respect to Q, derivative negative 0.6 with respect to P1, the length is 3. Then S partial of S with respect to Q times length, that's the value. You have to check that. S partial of S with respect to P times length, that's the value. It is an inner member also. Member 2 is an outer member, so this is the stress derivative with respect to Q and with respect to P0, length 4. So it is an outer member, blue. S partial of S with respect to P times length is 0. Then this is member 3. You do the same thing, partial derivative of stress with respect to Q1 with respect to P, negative 5/3. Then evaluate this value and this value. Those are the values. Then member 4, you have to check just to shorten this video. And for the viewers to check also, do not just watch. You have to check these values, these tabulations. Then 5 derivative with respect to Q, negative 0.6 with respect to P0. It is an outer member again, so blue. So negative 0.6 Q times negative 0.6 times 3 is 1.08 Q. Then here it's 0. Next is we add this. Then take note that P is just invented. We add corresponding members, inner and outer. We supposed to multiply this by 1000 square divided by area and E, which is 200,000, but 1000 square and E are common to the calculation, so we just ignore them. We can cancel them as follows. This table here, this column here is for the deflection, vertical deflection at E. So first we add this column divided by EE, corresponding EE. So 1.08 plus 5 plus 5Q plus 1.08 plus 5Q is 11.08Q. Then negative 1.8P, negative 25P over 3. That's the value in terms of P. Then the constant 81 plus 1125. 1206 area is 500E. Then the common factor 1000 square in the numerator, we just do not include that because the blue ones will be multiplied by the same value, divide by same E, except for the area. And we equate it to 0 because the work done by an internal force Q is 0. So 6.2, 2.56 plus 2.56 plus 1.08, that's 6.2Q, then negative 64P over 15. The constant, negative 192 plus 768. 576 area, 750 E equals 0. Multiply everything by E, so cancel E. Set P 0. Then combine, we have 1141 over 37,500Q plus 159 over 50 equals 0. Solving for Q, Q is negative 104.514 kilonewtons. That's the bar force of CE, and it is in compression. Then we add this row here. Again, we ignore the value of P because it is just invented. Then we already calculated Q from these results, but this time we multiply the numerator by 1000 square. We divide it by E, which is 200,000, to express the answer in millimeters. So delta E vertical is negative 1.8, negative 25 over 3Q, that's negative 152 over 15Q. 3P, 125P over 9, that's 152 over 9P. The constant, negative 135, negative 1875, negative 2010. Quantity times 1000 square over area 500, E 200,000. Then for the blue, this is just the result. Just copy that. Negative 64Q over 15 plus 64P over 9 minus 1 to 80 times 1000 square over 750 to 100,000. Then set P equals 0. Substitute the value of Q, which is negative 104.514, and obtain delta E vertical equal to negative 15.07 mm. So that's it for this video, students. This is a basic problem, and I think only few of you were able to solve this, just the force, but the deflection, none. So that's it for this video.